name is Arun Gupta. I am the Vice President and General Manager for Open Ecosystem at Intel. You can find more about us at open.intel.com or on Twitter, open at Intel, or Twitter or X, whatever. Or catch us on a podcast at open.intel.com/podcast. Today, I'm very happy to have John with me. Hi, John.
Hey, I'm Jon Moroney. Nice to meet you all. I work at GitHub in the security lab. I've got some slides set, which I initially thought this was more of a presentation style, and it's more of a hallway track, I guess. So,
It is
whoops.
absolutely on how we track. What we do in these things is I've been having these conversations with people anyway, and this is an initiative and attempt by which it really allows us to have that hallway conversation out in the open. So yeah,
Mhm.
feel free to bring out your questions, anything that you got, and we will try our best to highlight them over here. So John, you mentioned you work at Security Lab at GitHub. What is Security Lab?
Yes. So, let me just pop
Actually,
into the
let's
slides.
bring the slides up here because the slides are not
Oh,
visible.
yes. Sorry.
Okay,
Yeah.
here we go. Here
Um,
we are. Okay.
Here's the title slide so everyone can see it.
Oh, so the topic, actually, in a second, the topic is GitHub and open source security.
Right.
Essentially, what tools GitHub provides for open source developers.
Right. And so this talk or as a talk, it was intended to be a survey of four of the big tools that we provide, how to use them, why we build them, and where applicable, the sort of impact we've had. And so here's my intro slide. I'm John, aka Darakian. I'm not on LinkedIn, so it's a bit awkward that this is being streamed on LinkedIn, but whatever. I've got GitHub, and all my links are on the GitHub. So if you want to reach out, feel free. Happy to fill in anything that I missed, like during this talk. And yeah, so the Security Lab is a part of GitHub that focuses on open source security. We don't necessarily ship a product. We are more community focused, and we're focused on just generally securing the world of open source software for everyone. So we have these four main focuses, and these are finding vulnerabilities, building and engaging with community, amplifying the security research. This is primarily with a tool called CodeQL, which is the GitHub feature code scanning, which we'll get back to at some point. And then the thing I work on the most, which is the advisory database. And just to be clear, I'm talking about a lot of products that I don't necessarily deal that much with, so I might not be able to answer all questions here, but I'll do the best I can.
Security
Yeah.
Lab is not just research, but there are products that come out of it that are available to the customers.
Yeah, it's a mixed thing. So it's primarily research, but we try to engage with the community and have sort of tangible results that people can sort of get their hands on, and for learning purposes, and also to build their own tools. So CodeQL, which we'll get to, is a totally open source project, and we engage with the community to like help develop queries which help find SQL injection, cross-site scripting, that sort of thing, but like at GitHub scale.
Beautiful.
And so here are a few of the things we've done on sort of the research side, with links up at the top. So one of the researchers has found a certificate authentication bug in, like, I believe this was the TLS protocol itself rather than an implementation. We recently had a guy that I was working with a little bit find a remote code execution on the GNOME desktop, which I bring this up to make the point that we don't necessarily focus on stuff that is used by GitHub or developed on GitHub. GNOME is on GitLab in particular, although there are plenty of people inside that do use GNOME, or GNOME, whatever. And then, yeah, Chrome as well. So I think this was actually in the Chromium portion of Chrome, but point stands. And we recently hit a milestone where we're celebrating 500 CVEs that we've disclosed in the lifetime of the group. The group itself is about 4 years old. I've been here for it'll be 3 years in March. And this was very much just a celebration blog post of here's what we've done, here's how we've done it, and the salient point that I want to
Well, I
bring
mean,
up.
I think
Yeah.
it's sort of a bittersweet 500 CVEs. First
Yes.
of all, like, it's a proud moment, but it's like, what the heck? There are so many CVEs, and the
Oh my
CVEs
God.
are only going to grow. The cyber attack is only more imminent now.
Yes. And if you read this post, we've actually done quite a bit more than is captured by those 500. A big part of what we do is we focus on fixing things, not just finding them. So we have this 96% fix rate. Yeah, and yes, you're right. Like there's always going to be more bugs. There's always going to be more CVEs. The mental model I have that like we have these conversations internally is at GitHub, we keep track of how many users we have and how much software is being written every day. And specifically now that we have Copilot out there in the wild, the just number of lines of code being produced every day is just an upward trend. If you assume that there's some sort of constant rate of bugs per number of lines of code, which maybe that's a hand wavy number, it's not perfectly accurate, and then you assume further that some percentage of bugs have security implication. Yeah, that's just a growing number of security vulnerabilities, and CVEs are only the ones that are found. There are plenty out there that are never found, which is what keeps me up.
It's like a ticking time bomb. You never know when the next Log4Shell is going to explode.
Absolutely. I mean, Log4j, right? Like that was in there for years prior to it being disclosed.
So these 500 CVEs,
Yeah.
These 500 CVEs, when they are reported, who fixes them?
Good question. It depends. It's a combination of the researchers working on the individual report in tandem with the maintainers. And it sort of depends on who has the expertise, because of course the maintainer knows their code base better than the researcher, but the researcher may know the bug better than the maintainer. And I'm going to jump ahead a little bit here. Hold please. Is it? Nope. So we have this thing called private vulnerability reporting, which launched early this year, I guess. It's currently in beta, but in any GitHub repo, you can go to your security tab, click a button, and opt into allowing researchers to come to your repo and report a vulnerability privately. This will allow you to create a fork, which is private. It keeps all the Git commits in a private space until you're ready to disclose it so that you don't ODay yourself. It's opt-in at the moment, and there's a conversation about that because there are pretty strong opinions on whether it should be opt-in or opt-out, depending on who you talk to. And the maintainer voices seem to be much more opt-in, because the concern is that there are less scrupulous security researchers out there who would come around and just sort of spam you. That's a social conversation that we're going through, and yeah. But anyway,
I did not know that I could opt in for security researchers to come hack on my repo.
Oh yeah.
Tell me, how can I make it more secure? That's pretty awesome, actually.
Yeah, no, and you can give them credit, and we try to provide as much support as possible for this. There's a QR code for this as well for the docs later on, but yeah, no, this is one of the coolest features in my mind that has come up recently, because there's this tension between security researchers and developers in just how they want to operate. Like security researchers tend not to care about maybe that's too strong. Some security researchers tend not to care about the particular constraints that a developer is under, where they have to ship by yesterday. They might be on vacation. They might be taking a sabbatical to get away from things. And security researchers want to get CVs fast, and they want to get them published, and they assume everyone should sort of jump to that, or not all of them, of course, but like in the degenerate cases. And this is a feature which helps align social aspect of that, and sort of puts the developer a little bit in the driver's seat of the disclosure process. And we've seen some really good results with this. Like, people love it. Our entire org internally this is how we report our vulnerabilities to anyone on GitHub, at least.
Beautiful.
Yeah. So let me jump back
Okay,
up.
let's go back to the flow. See, because when I think about security for open source developers offered by GitHub, the kind of things that come to my mind, well, dependabot, of course, is a standard too, that is available to everybody. Not sure if everybody knows about it. CodeQL is something that comes to my mind. The security tab that comes to my mind. So I would love to kind of dig into those and see what's going there.
Yeah, let's. So leading in, so yeah, GitHub more generally than just the security lab. There are a bunch of security features. I'm scoping this talk, of course, because there's a lot to talk about. We do a bunch of passkeys and 2FA and stuff. Most of that I'm going to skip, and I'm going to try and focus on the stuff that like leads to more secure code. Because I think, well, my intuition is that's what's more relevant to this audience, but happy to be told I'm wrong too. So. Also, as an aside, if you want to look up any of this stuff, we have this product suite called GitHub Advanced Security, or GAS, as we tend to refer to it as. This is sort of the umbrella term for all of these products. So if there's something you want to dig into, just Google that, and it'll get you in the right place. So another one we have is secret scanning, which is a relatively recent thing, where there's a few modes of operation here. The coolest in my mind is the push protection. So if you go into your security tab, there's a secret scanning button and you turn it on, and there's a few different options depending on how you want it to work. Push protection is that for a bunch of known patterns of like AWS tokens or GitHub tokens, Google Cloud, there's a big old list. If GitHub notices a token like that, which is being pushed up to one of your repos, it will reject the commit, and that token will never actually make it into the repo. And so someone who is going and scraping the repo constantly, which happens, will never see the token. It's a way of just preventing errors from occurring in the first place.
So from a developer perspective, it's as simple as just turning that option on and that's it. Voila.
Exactly. In fact, let me pop open a repo. So if you jump into your security tab, there's secret scanning, and yeah, so there are no secret. Well, let me see if I can. I don't think I have it on in this one yet, because this is my repo for like doing vulnerable stuff.
Yeah.
So you know, it's telling me secret scanning is disabled. Click in. Oh God, it's been a while since I've done this. Yeah, enable.
That's it.
That's it. And then you can enable push protection as well. There are reasons you might not want to do that for like testing reasons and so forth, but the option is there. And more recent, like this is its own product stack. There's ongoing support for what patterns are supported. Do you do custom patterns? A more recent one, which has been put on, is this validity checking, which there are cases where you might want to push a token up to be part of a test suite, say, and you want it to be an invalid token or an expired token for your own logic. And so to reduce noise, we will do validity checking, and if it's not a valid token, we won't alert you on it.
That's beautiful.
Mm-hmm. Yeah, so yes, there's different patterns for what you want to do, whether it's alerting or blocking. Alerting seems to be much more, alerting is way more useful if you have a bunch of old repos that existed before this feature did, that you might want to retroactively go and, see if there's something up there that you don't know about. And if you go to this link at the top here, that will send you to the list of all the patterns. And so the next one is code scanning, which briefly touched on. This is powered by CodeQL. The basic idea is that if we, I think most people accept that SQL injection is bad. It's a pattern we don't want in our code most of the time. Certainly, there are testing scenarios and so forth where we might want this, but generally speaking, there are patterns that we know we don't want in our code. And so the idea of CodeQL or code scanning is if we can represent those patterns in some abstract way, we can go and look for it in everyone's repos. And that's exactly what it does. And so this is a code scanning, or sorry, this is a SQL injection example of code scanning, where we're finding a SQL injection in some Go code. And the way this works, similarly, you would go to your security tab, you turn it on. This is more complicated, as you do have to choose which queries you want to run, and the queries themselves do get complicated.
So CodeQL is like a query language in which
yes.
you can write on what kind of code to be scanned.
Yes, exactly. And so you can think of it like SQL, but for your code. And the idea is very much the same, where if you ask of SQL, show me all users that have a registration date before the 1st of November, 2020 or whatever. The high level concept of CodeQL is the same. Show me everywhere in my code where, let's say, user input comes in from some source and goes out to some sink. And if you know that sink hooks up to your database or shoots out to like a web page render or something, you can trace user input and find bugs that way. You can also just look for static patterns, and there's a mix of these, which this is all open source. Here's the landing page for it. If you want to get the high-level intro, this is what some of the code looks like. And then this is the repo for it. And this is all open source. All of the queries are in there, although the structure of that repo is not my favorite. But if you're willing to dig, it's all in there. And you can just go and look at the PRs. This is part of what the Security Lab does too in the promotion of our community efforts, where we have essentially a bug bounty program, or a bounty program maybe is the better way to put it. We give out awards for people who come up with good queries. Good being a high amount of coverage with a low number of false positives.
Right.
Because as you can imagine, with anything, there are false positives. And this is the sort of tension with CodeQL of writing a query. How specific do you want it to be? The more specific it is, the fewer false positives, but also the fewer positives generally you get. And it's
fewer impact that you can get as well. Now, is CodeQL language dependent? Like, does it work for Go, or does it work for Java or other languages? How does it work?
So it works. Yes, it's code. It's language dependent. It works on a number of languages. So we've got Go, Java, JavaScript, Python, Ruby, Swift, C#, C++.
Also, there's a full directory for each language, and that can itself.
Yes, and so the queries are also language dependent, or at least that's my understanding of them. I don't know if you can have language independent queries, but there are a number of libraries, I suppose you'd call them, that are language dependent, and so you can hook into. I think I have on the next slide an example which we can pop open. Yeah, so here's a SQL injection one which we can pop into. And you can see there's a whole bunch of imports going on here. And these are language dependent imports that give you the ability to inspect the code as that code is itself internally represented, because the structures of any given language don't necessarily have to be the same.
So one more question on CodeQL. Yeah. Is this a static thing? Is it a dynamic thing? Is it a runtime thing? What point CodeQL runs on your repo or your binary? Where does it run?
So it's a static thing. Given where GitHub sits, we host people's static code. We don't necessarily have access to the dynamic portion. And so this is a static analysis tool. Or at least today, it is only a static analysis tool. And the idea, and so, yeah, indeed, there are some bugs that are going to be hard or maybe impossible to find with it. But the benefit of it being a static analysis tool is that you can hook it into, say, a PR review step where you might have a requirement that all of your CodeQL queries pass before a PR can be merged. And this would prevent you from introducing a cross-site scripting vulnerability, or I've had one hit me where I had a regular expression that, even though it was an internal application, the regular expression had exponential growth. And so I had to go and fix that before my PR could get merged.
Got it.
And so that's
all. I love that statement. All CodeQL queries be passed until PR can be merged, and that's the automatic step that you could incorporate as part of your CI/CD process itself.
Yes, and every one of these tools is designed to be in the developer workflow as essentially just a little checkbox on the side. No one's going to use tools that aren't easy to use, and a big part of our philosophy is that security tooling has to be easy to use if we actually want people to ship better code. So we're doing that.
Well, and security is hard, and if you make using it harder in that case. So yeah.
Yes. Yeah, and there's, I mean, to get onto that too, there's this, there are these old terms like PEBCAC, where like blaming the user, or in this case, the developer,
right,
was and sort of is in vogue in some circles. And it's sort of not acceptable if we just want, as security people, we need to make this easy. We need to meet our users where they are and not just denigrate them.
It's very easy to point the problem at the person who's not there.
Oh yeah. Or just say you're holding it wrong, right? It's like, well, maybe, that can happen, but also maybe you built something that you can't hold very easily. It goes both ways.
Correct. Beautiful. So secret scanning, code scanning, what else you got?
What else do I got? Well, private vulnerability reporting, which we already touched on.
Yeah.
Again, this is, I think, one of the cooler things we've shipped recently because it's less technical and it's more social. And the social aspect of security is often overlooked, where, people dropping O-days is something that a security, it's almost a point of pride in some circles of security, where people want to drop an O-day because it's a big deal. But PVR tries to reorient that and make it a bit more constructive and less, there's less bravado in it. It's more like, hey, let's just work on a fix and ship a fix and not fire off alarms and wake people up at night or call them in from vacation or whatever.
So when you say O-day, you mean 0 day, right?
Yes, sorry, a 0 day.
0 day. So for people who don't understand, what does a 0 day vulnerability mean?
Good question. Sorry, I'm using terminology I should define.
That's all right.
So a 0 day, you can generalize the term. There is an N day, where N is an integer, and it's how many days since the vulnerability has become known. And a 0 day is a vulnerability that is dropped like immediately. It is when the vulnerability is immediately dropped. And so that is the point at which operations teams would have to react to that. Depending on its severity, depending on what it touches, there are vulnerabilities that nobody in the world cares about. Well, I've got examples of those later too, or at least subsets of people in the world care about. And that's the whole thing of like, who cares about what vulnerabilities? But if a vulnerability affects you and it's dropped, say log4j, if you're using Java, you have to react instantly. It's a huge deal. Alarms start going off. People get woken up. English. It's a bad time for people. And PVR tries to address that in the idea that like it keeps things private until the maintainer is ready to go public. And you can coordinate the time at which it's going to go public with stakeholders that matter, with customers that matter, with whoever. Or you will have already shipped a fix, and you can wait until the fix is widely deployed.
So maybe a bit of more of a philosophical discussion. What's in it for people to share the vulnerability as opposed to here is the vulnerability and here is the fix?
Share with who?
Like, people say, oh, I found a vulnerability, boom, it's out there, go figure out a fix, as opposed to there's a vulnerability, it has been reported, and it's a patch available, and here is the patch. So
Yeah.
why there has to be like a lag time or a lead time between the two? Why can't it be vulnerability, fix, and ready and deploy?
Well, so that's what PVR tries to get to, is where the
Gotcha.
vulnerability.
Oh, I see. Okay, so that's the
is-
problem. Okay.
Yeah. So the problem, just I guess to reiterate or to rephrase the problem, if someone goes on Twitter and publishes a vulnerability, let's say, the maintainer of that software first has to be informed about it, which is generally some random side channel through a colleague or a blog or whatever. Then they have to validate that it's real. Then they have to figure out what's actually going on and develop a fix, publish the fix, publish the resolved artifacts, if there are artifacts, if it's not just a repo that people get cloned or whatever. And all of that is done under pressure. You've got customers who are yelling at you. If you have customers or users, whatever, it's not a good experience, and it burns people out.
Got it. Okay, that makes sense. Okay, all right.
So yeah, PVR, and then this is what it looks like to the reporter, where they would also go to your security tab, and then if you've enabled it for your repo, there will be a button for them saying report a vulnerability. Very straightforward. And then the next one is dependabot, which is my favorite because I sort of work on a fraction of it. Dependabot launched, well, it was originally a separate product altogether. It was a GitHub app, and then it was purchased by GitHub, and now it's a sort of pretty core feature of the GitHub platform. And there are basically two modes of operation for it. One, you can use it as a security scanner, which I think is probably the more popular way to use it, where it just watches what you're doing. It looks at your manifest files and says, this is vulnerable, please upgrade to that. Or this is vulnerable and there's no upgrade, please read this thing and, pray or whatever. It can also operate on a mode where you just always want to update, whether that's to a minor version or a patch version or a minor version. Maybe you care about majors. It can just be an automatic update tool as well, if you want it to be. I'm going to focus on this.
When you say packages here, is it Java packages? Is it Go packages? Is it C# packages? What does the term package mean?
Yeah, good question. It's all of those you've mentioned, but it is a finite list of packages. We have this ecosystem model whereby we define what a package is in different contexts. And let me just jump ahead to that because that's a meaty topic. Here we go. So this is our set of currently supported ecosystems, and each one of these is a namespace. If you see going back one slide, if you see the term Lodash as a package, it exists today in at least 5 different places. And so in order to build a reliable update tool, you need to have more information than simply the word Lodash. The CPU system is what MITRE or NVD or one of those organizations defined in order to allow for a programmatic targeting or a programmatic, I'm just going to use the term targeting of advisories to a product. The problem with that is there is no so CPE is a standard, but it is functionally unstructured text. It is like a vendor followed by an application or a product and an application. It's something of this nature, but you can't know what a given CPE string applies to unless you've seen it before. Whereas with our system, you can do a direct lookup without knowing the product ahead of time, which is this, where there's a one-to-one correlation between a tuple of our ecosystem and package name and a package in a registry somewhere, or set of packages really, but because we also have version information.
So there's a taxonomy here which kind of says here is a namespace, so that in case you find Lodash vulnerable, you don't know whether it's Go, whether it's C, whether it's Java. and then
Yep.
it qualifies that namespace, and then comes the version. And as you were saying earlier, you could say just alert me, or you could say just automatically upgrade to the next version so that I'm always on the most latest one.
Exactly. And yeah, so this does scope us. We obviously, like, we're not doing everything. We're not doing Linux packages, for instance. To that point, the Linux distros do already have security updates in place. So we think we're hitting a place where there's a lot of value, where this hasn't really been deployed at scale before.
So behind the scene, help me understand, how does
Yeah.
dependabot kind of keep track of, you and I were talking about Maven, for example.
Yeah.
Millions of packages across, thousands of repositories.
Yep.
How does dependabot know that here is the project that I'm looking at, and what is the latest version, and whether there is a vulnerability reported in or not? How does that work at the back end?
Yeah, so dependabot will scan a manifest file that you put into your GitHub repo. In the case of Maven, the packages are these days tied to DNS lookups, and so there are thousands of registries, and there doesn't necessarily have to be a namespace, like respected namespace between them. In practice, there is. That is a gap we are working on to like actually make that foolproof rather than just sort of happenstance. In fact, since we do everything in the open, we have an issue about this actually. So this is our repo for the database itself. PRs are welcome. Please bring evidence with your PR, but PR is welcome. So we have, does the advisory database cover other Maven repositories? And here's my reply. So the way we structured this at the moment is for historical reasons. We have users who are using Maven advisories for a number of things. The Jenkins project has basically moved to our database entirely as a source of truth for its own update system. And so we don't want to break that functionality for them. The Jenkins project also runs their own package registries, although they own the namespace for those packages on Maven Central as well, which should prevent a namespace conflict. Anyway, the long story short is there's an issue here that if you have strong opinions on, you should come and comment. So essentially, there's just a conversation ongoing about how exactly to handle this and how to move from the world we're in today to the world we want to be in.
So let's think about the workflow for a second. Now, there is a vulnerability identified in some Java package.
Mm-hmm.
That is, hopefully they're using PVR, in which case the vulnerability is reported, fixed, and automatically updated. That's all clean. If they're not using PVR, let's say some security researcher want to report the vulnerability and say, now work towards the fix, and the fix happens.
Yep.
How is dependabot or Maven connected so that they find out and then they convey that information to the repository that, oh, you know what? Your repo has unpatched security vulnerability.
Yep. So that connection is me and my sub-team within the security lab. There are a couple of us that are watching or reading CVE feeds constantly. In fact, that's what I'm going to go do after this talk. And we read them, we assess them, we attempt to find the packages that correspond to them, and then we enter them into the database. This is something we are attempting to automate, but among other things, there are simply lies that get published with CVEs.
Oh, I'm about to ask that.
Yep.
I'm surprised that this is still a manual process and we are not using ChatGPT or some AI-powered tool for this.
We're experimenting with that sort of thing, but like the cost of a false positive is very high.
I agree.
And so the hallucination, the cost of hallucination is therefore very high.
Yeah.
Stuff like this happens. So this is a CVE so leading into this section of the talk is like, sort of to your point, it seems easy, right? Just find the packages. Sometimes, so the CVE system is a weird federated system with different parties that have different goals and different standards of operation. Sometimes CVEs can be assigned and never actually uploaded. People will talk about them in blog posts, and so you'll see hints of like, such and such project is vulnerable in such and such way. Please see CVE whatever for more details. And sometimes this happens, and the details just never actually made it out of whatever organization. Stuff like this happens. This is an older one where there's maybe a vulnerability in something, but no one knows really what. There were a bunch that I went through last year where there was one researcher who said there was remote code execution in 20 or 30 PyPI packages. The proof of concept was a pip install, which had this, I think it was -i flag, which defined an alternate registry to download the package from. And it was controlled by this individual. So sort of naturally, yes, there could be remote code execution.
Yeah. Well, I mean, and I recently started seeing in ChatGPT, at the bottom they say, ChatGPT can make mistakes. Consider checking important information. So yeah, it's early days. And I was also listening to an interview by Sam Altman on Hard Fork, which is a wonderful podcast by I just started listening to it, really good. And he talks about that, AGI, the concept that we talk about, artificial general intelligence, is out there, 2028, 2030 timeframe. So experimenting, I think, as you said, is the right way.
Yeah.
And gives confidence and faith that GitHub is going to do the right thing.
Yep. Yeah. On that topic, we are more looking at AI as in the sort of the PVR workflow, or because from any GitHub repo, you can go and make a security advisory about your own project. There are opportunities there to add AI assistance to that, of like, what is the vulnerable fix command? What is the vulnerable piece of code? What type of vulnerability is it, to someone who might not be familiar with this? So there's work ongoing, but it's, the product has to be good at the end of the day. And that takes time. Like, good is not something that there's necessarily an algorithm for.
Yeah. No, I understand that. Okay, beautiful. So how can, those are the two modes, and he says alerting is a more popular mode. What else we got within dependabot?
Honestly, that's all I have on dependabot.
Okay, that's nice. No, that's pretty cool. What other tools?
Well, so the other tool is the advisory database itself, which, where is it? So this is the landing page for the database, and this is sort of my follow-up, like, who am I slide, and what I do. And as we've already gotten into, I'm a bit of a librarian. I categorize information so that it's useful to whatever tools. Our goal is to have correct, complete, and concise information that lands in whatever context that it's read in. And the idea there is that we want people to actually action on advisories. This is a sort of a comic which depicts, I think, a pretty common behavior. Certainly I did this when I was younger, more with compiler warnings than anything else, but this is what we want to avoid, because we want people to actually fix their code. The code that they ship ends up in products we all use, whether they're phones or computers or cars or microwaves or whatever, pipelines. Like, we all have a vested interest in this stuff working as expected. And so this is what we're trying to address this is what me and my team are trying to address directly, is the alert fatigue problem, where people get alerts which aren't relevant to them, and having better data is a way to address that. There was this blog post which was written a few years ago called NPM Audit is Broken by Design. And NPM Audit is another tool that uses the GitHub advisory database to power itself. I disagree with the title of this blog post, but I do agree with the general sentiment of The author writes that they're getting a bunch of advisories for dependencies that are only ever used in a dev environment. They're getting regular expression denial of service vulnerabilities for packages that they never actually send user input to. The context in which they're using the package means that the vulnerability is not relevant to them. And that's a hard problem. Like, an advisory needs to be written in a generic way so that it can be delivered to all users, and every user is going to have a different context. Denial of service itself is a very different thing, whether it's in like a child's toy or whether it's in a car driving down the highway. Like, denial of service has very different human implications.
The context, is all what defines it essentially. And the point that you were saying is the previous slide, essentially, where you said false positive, right? And that's what the alert fatigue is. How do you make sure in that noise that this is the right thing for me to act upon? Like, I don't want this to blow out of proportion by ignoring that one log for shell.
Yeah, no, it's hard. So we recently, I guess, sorry, I lied earlier. I do have more on dependabot for you.
Right.
There is constant work ongoing in dependabot. We recently launched these auto triage rules specifically for this problem, right? Like, we don't yet have the ability to know what your context is. So we're giving you tools to better, to enable you to better triage the alerts that are coming to you. Step one was, we'll have this one-to-one correlation of package to vulnerability. Therefore, we're getting rid of a fuzzy match, which used to exist in the CVE world, where we sort of heuristically think this might apply to you. Now we know it's something in your dependency tree. But indeed, we're now missing the context of, is it something that's relevant in your dependency tree, or is it sort of sitting on the side there? And we're working on that.
And the premise here is really providing those tools where users can define the context, and then they can make a call whether it's a false positive or not.
Exactly. And if you go to our blog and just search for dependabot, if you notice the timestamps on here, we've got a lot of work ongoing around grouping of updates, the triage rules, some stuff about rerunning jobs. Like, we're constantly working to make this a better experience, and it's just genuinely a lot of work. One thing I will skip ahead to as well. So finding the packages is one part of the problem. We also need to know what versions are vulnerable in order to deliver something like this, where we say, we're bumping Django from some version to some other version. That requires knowledge about versions. And it turns out math is hard. So semantic versioning, if you're old enough, semantic versioning was supposed to solve versioning. Because everyone did versioning differently, and now they're on version 2.0.0. And funny enough, there isn't really a changelog. So unless a package tells you what version of their versioning scheme they're using,
right,
when you're writing an inequality statement saying versions less than 1.2.3 may or may not apply. Here's an example of Semver. This is a project that I work on. Someone came and sort of yelled at me that I was using the wrong version of Semver for my project. In this case, the crates/Rust world has its own version of Semver. And this is, I think, the biggest problem with Semver is that it is not actually that simple, but it looks so simple, everyone thinks they can intuit it. And so in practice, there are like 8 or 9 Semvers out there, which is lovely.
So it really depends upon which version of Semver are you using, and then your versions may not be matching.
Yep.
And that kind of blows the problem completely out of proportions.
Yes, exactly. It leads to that false positive issue. This happens. So in the Python world, they don't use Semver necessarily. They use this PEP 440. This guy Seth Larson did a fantastic post on like what is a version in the Python packaging world. The bit I want to point out there is the top line. There was a PEP, which is like a standard for how you do this in Python, and then it changed to a different standard at one point in time. when the second standard came out, 97% of packages were captured by it, which means there is just legacy stuff out there, which we have to account for. We hit this, so it's even worse in the Maven world. If you go and look at the documentation that Sonatype provides, which I don't think I have in this slide deck, but I can get you. A version for a Maven package is any string that doesn't end in -snapshot. So you can do plus snapshot, but not minus, which of course means our ordering can't necessarily be standard across every advisory in every ecosystem. And these are the sorts of problems that make dependabot a hard thing to build and to make it work the way everyone intuits that it should.
Got it. Are there any capabilities in dependabot to auto remediate that? You find the problem, you know what the fix is, just fix it for me, send me a PR, let it run through a system, and then fix it up?
Yes, I believe there is. I believe it'll automate. I should have put this in here. I don't know where the documentation is at the moment, but I believe there is you can go and say, just open a PR, and then if you have a bunch of tests, it'll run your test suite. That's just part of the workflow. And I believe it's not dependabot, but it's just a different part of GitHub that allows you to auto merge PRs that pass your test suite. So yes, you can in theory fully automate this path. There's also another thing that was announced at GitHub Universe, which is our big company conference earlier, or I guess technically last month now, where we are introducing this AI autofix component for, I believe it's attached to code scanning, where if we find something in your code, we will attempt to make a PR to fix it for you, which also very cool.
That's beautiful. That's all that fun. Can we take a look at sort of the security tab of the repo that you were showing and see what other fun things are there to improve the security for developers?
Absolutely. So security tab, here's your security overview.
And so anybody who creates a brand new repo will get the security tab?
Yes, this is standard on every repository. So there are a number of things: secret scanning, code scanning, dependabot, PVR. Security advisories are the dependabot alerts as relevant to with security relevance on them. The last one on here is setting up a security policy, which is a document to tell researchers how to interact with your repository. What is your timeline for disclosure? Do you want to be emailed? Do you want PVR? Whatever. So the other thing, I guess, to point out here is you can make advisories yourself. And so you can go and make a new draft security advisory and say, I don't know.
And so I would do this, for example, as a maintainer of the project, that I believe this is a security advisory, and this is level such and such, and here you go.
Exactly. You can request a CVE through this workflow if you want. We, at the moment, have a drop-down, which is not my favorite from like a UX perspective, but that is what it is. You can request a CVE later, write your description. You can select your ecosystem if it's relevant, or you can put in whatever you want. What happens in this flow is it's sort of unstructured text, and you can go through and create this advisory. And I'm just not going to, because that will end up on my desk, so to speak.
So and that's what you said, right? CVE is an unstructured text right now.
Yes, and yes. So those hit me and my team. We will do our due diligence to research it to make sure it's correct. It's talking about a package that the maintainer has authority to talk about, and then we will republish it to our global database to power dependabot alerts, assuming it can be validated. So that's a powerful tool if you want to communicate to your users in a sort of automatic fashion.
Okay. And what about the other ones? So dependabot, are there other detailed options, or they're like pretty much just refining?
It's pretty much just the configuration.
We talked about the auto triage, your alerts. That's your vulnerabilities over there. Code scanning. Okay, what else? So I think I hear opt-in security Private vulnerability reporting. I learned about security scanning. I learned about code scanning. I learned about dependabot. I learned about how the advisory database, you can create your own advisories. That's a pretty good set of tools.
Yeah.
Where do you see developers? What do you think is the most underutilized, most uninformed tool from GitHub to the developer for security?
For security, probably code scanning. I think so there's been a lot of code scanning came in from an acquisition. It is for a long time it was fairly cumbersome to set up. There's been a lot of work going on to make it easier. I have not actually set it up, so let's see what the state is right now. Was that just on already? Okay, I believe that may have been made better already. It's been so not my project, so I'm not super familiar. But yeah, so my language isn't supported, but this project has no code in it. It's just a manifest file. So it's but code scanning is probably the most underutilized, in part because it is a complex tool. I will say we do have a Security Lab Slack channel that I would welcome everyone to pop into, and I wish I had the link on me, but it's on our Security Lab page. Or feel free to reach out to me, and I will get you the Slack link. This is where the community is for this. There are people who I'm sure would be very happy to help you set it up.
That's pretty awesome, actually. Jon, this has been very helpful. Anything else that you want to share today in terms
Yes.
of recording?
So I just want to run through the last few slides.
Please.
First, I want to say, like, on our ecosystem model, we have seen really good feedback on this. This is a blog post by another company called Anchor. They do container scanning for like Docker and Kubernetes stuff. They recently put out this blog post called "Say Goodbye to False Positives," and the thrust of the article is essentially, "Hey, we moved to GitHub's ecosystem model, and false positives just go away," which is fantastic validation for our work. And so I just want to share that. This is one of the co-authors speaking at GitHub Universe last month, and specifically calling out the ecosystem model in the talk.
Mhm.
Aside from that, we've got APIs. So the database is in two parts. There's the global perspective, which is the stuff that we curate and that we stand by and say, this is truth. And here's the API for that. There's also a GraphQL API if you prefer GraphQL to REST. Links, QR code. You can also get access to the raw repo data, that unstructured text that isn't validated. But if you in your own organization have some scope that, or some naming system that we don't support, you can absolutely build your own tool on this. You do have to maintain coherence to that standard yourself, but if you can do that, the tooling is in place for you to go and build a dependabot for your own project or whatever you can build.
So this is the API that you use as well within GitHub to build the dependabot, and you're saying others can use to build their own version too.
Yep. I think it's a little bit different. We might hit a different endpoint because, like, this one is rate limited for reasons.
Sure.
But yes, same thing, same data. PVR, again, I would just really express to everyone, turn this on. Think of it as an insurance policy. Set up a security.md file that says, hey, go use PVR to report things. The feedback, the qualitative feedback we've gotten from people who use this is just fantastic.
I can imagine, you're basically creating a safe space for people to report, and a conscious and a deliberate effort that, hey, this is a place where you can report and we'll work with you directly on a high bandwidth.
Yep, exactly. And it credits the reporter too. So when the advisory eventually gets to our database or to the repo advisory, there will be a credit for that user, so they can go and brag about that, put that on the resume, whatever, which they enjoy. And then the dismissal rules, again, targeting advisories is a hard problem. We're working to make it better, but do your due diligence with the dismissal rules, because of course it's very easy to get it wrong and then to ignore security advisories. However, you can also just turn off dependabot, and we're trying to keep people from that. And so it is a better world where you can have some control over the noise level that you can tolerate. And so that's what we do. This is, from the database side, this is basically an infinite amount of work. We are constantly working to improve our data. People come and give us PRs all the time. I've got actually like 20 waiting for me to get to today. All of our data is Creative Commons licensed. So if you have an interesting use case that is beyond the security scanner, we'd love to hear about it. PR is welcome, and yeah, help us make this the best database for everyone.
That is beautiful, actually. I think this is tremendously helpful and useful. I learned a lot of new things about it today. And John, send me some of the blog links or the slides that are available. I'll make sure I post them as part of the LinkedIn message so that people have access to these things, because this is really wonderful information. So,
Will do.
John, any other parting words that you have for the audience today?
I guess the only thing I would say is that security is contextual and it is social in addition to being technical. If you're a maintainer, have some empathy for the researcher, even if they're a bit abrasive. If you're a researcher reporting, have some empathy for the maintainer who might think you're just barking up a tree or something. But we're all human in this space. And the goal is not to pad a resume or to damage someone's reputation or to prevent your reputation from being damaged by saying, oh, I've never had a CVE. The point is to ship more secure code and to make sure we all have a better set of software that we use in our day-to-day life.
Yeah, very well said, actually. As you said, is contextual, social, in addition to being technical. So just having that empathy, for both ways goes a long way, actually. So thank you. Thank you, John, for being on the webinar.
Yeah,
I really
thank you for having me.
Hopefully, yeah, absolutely. And we will see you some other way. Bye-bye.
Sounds good. Bye.
Thank you.